You might recall earlier in the week we were talking about a problem in which we were given a function g of x, which described the height of a tree in relation to its diameter, and we were asked to find dg dt, the rate of change of the height of the tree with respect to time. Now, many of you, if you recall, started by finding g prime of x, which is also known as dg dx, and I pointed out that that's not exactly the quantity we needed because it doesn't relate to time. However, we could use dg dx and multiply it by dx dt in order to get the rate of change of g with respect to time. I wanted to talk today about a similar problem, another free response problem that I found that I think would just give you another problem to consider when discussing this sort of concept. So this is about a funnel of height 10 inches. Its cross sections are circular, and we're given the relationship between the radius and the height of the funnel by that equation right there. We have liquid that's draining out of the bottom of this funnel, and we're asked to find when the height of the liquid is 3 inches and the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second, we're asked to find the rate of change of the height of the liquid with respect to time. Let's take a look at that phrase. Height of the liquid with respect to time. That sounds like dH dt. Up here, we're again told the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. That sounds like dr dt. And of course that the height is 3 inches at the time we're looking. Now let me go ahead and rewrite our equation in an equivalent but just slightly different form by distributing that 1/20th. Many students would be inclined here to take the derivative since we are looking for a rate of change, and r prime in that case, the derivative of a constant is 0, would require the power rule here, and we would get 1/10 h. The problem with that derivative is that if you analyze it further, you'll realize that what you just found was dr dh, the rate of change of r with respect to h, or the rate of change of radius with respect to height. We didn't at all consider the fact that the quantities we're looking for are being taken with respect to time. So instead, what we should do here is use implicit differentiation and the chain rule to get the desired result. Let's go ahead and take the derivative with respect to time. On the left-hand side, we're going to get dr dt. We still have a constant here that will go to 0, but we'll get over here 1/10 h dH dt. And you can definitely now see the quantities that were given and how they're going to play out as we finish this problem. So dr dt is given as 1/5 inch per second. Don't forget that the radius is decreasing, so we would want to put negative 1/5 in there. And h is given to us as 3, which allows us to solve for dH dt. Again, we wouldn't have had this dH dt component there had we not differentiated with respect to time. Solving this equation, dH dt, gives us the desired answer of -2/3, and our units would be inches per second. So this is just a reminder to make sure when you read these types of problems that you really pay attention to units, and especially pay attention to the variable with which you are differentiating with respect to.